Welcome to this predicted paper from onmaths. This paper represents the best guess for the upcoming exams. Please use this paper in addition to your other revision. You can complete a unique version of this paper by going to our onmaths site. Onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions, and mini mocks. If you like what we do, please consider subscribing. So to find the gradient, we need the formula or the equation in the form y equals mx plus c, and the m there will give us what the gradient is. So we're just going to be rearranging this equation. And so I'll get my lines in. So the first thing I'm going to do is get rid of the x's from the left hand side, and we can do that by adding 6x both sides. So we've got 6y equals, and I'm going to put the 6x first, just to match the y equals mx plus c. Right, the next thing I'm going to do is get rid of this 6, because we just want a y there. So we're going to divide by 6 both sides. So we've got y equals 1x plus 36. Now we shouldn't really write 1, but because we're looking for m, we're looking for the number before x, I've kind of left it in there to show that the gradient will be 1. We can't work out what x is straight away, but we can find this value here. And we know with Pythagoras we can find a third length if we've got other two in a right angle triangle. So a squared plus b squared equals c squared. And a and b were labelled. C is always opposite the right angle, so it'd be 49 squared plus b squared equals 68 squared. And 49 squared is 2401. And 68 squared is 4624. So we are solving here, so let's get our lines down. And we're going to start by subtracting the 2401 from both sides. So we've got b squared equals 2223. Then we're going to square root both sides, and we've got b equal to 47.148, blah blah blah. Okay, we're now looking at the second diagram, and this time we're going to have a, we've got our b, and we're going to call x the c. So it would be a squared plus b squared equals c squared, but this time a is 39. B we are given as 47.148, we've just worked that out. And we're looking for c, in fact we can call it x now. Okay, so we need to square that. So we do 39 squared plus 47.148 squared, and that will be 3744 equal to x squared, and we'll just get our lines in because we need to square root both sides, and we get 61.188 blah 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 is equal to x. It says it wants it to 2 decimal places, so that will be 61.19. So to find the area of a rectangle, we just multiply the width and the length. So that's what we're going to do here. But whenever you have an expression representing a length or a width or anything really, you just put brackets around it. So we go u minus 2 times u plus 9. Okay, and the way we do this is with our grid. And just going to draw out the grid. And so we've got u minus 2, and we're multiplying it by u plus 9. Don't want too many for some reason. And so we've got u times u, which is u squared, u times minus 2, which is minus 2u, 9 times u, which is 9u, and 9 times minus 2, which is minus 18. And what we're going to do is we're just normally going to be able to add these ones together. So our answer will be u squared, And then we're going to do 9u plus minus 2u. Well, that's just going to be 9u take away 2u, which is 7u. So plus 7u, and then minus 18 at the end. So I'm going to start off just with a quick sketch. And we know that the bearing of B from A is 85 degrees. So we're going to have A here and B here. And let's just draw a line between them. And let's do both our north lines. And so we know that this angle here is 85 because it's the angle on the bearing of B from A, so it's 85 degrees. So now it says work out the bearing of A from B. So the first thing we can do is actually just draw a line going down here. And we know that this angle here will also be 85 degrees. Because of alternate angles. It's always best to write that down somewhere, so we can just put in brackets here alternate angles. And we know that this angle here is going to be 180 degrees, because it's a straight line. And I'm not a fan of doing the reasons on the diagram, so maybe perhaps I should have labelled this an x and this a y and written x equals 85 and y equals 180 somewhere else. And so to work out what the bearing is, I just need to do 180 plus 85. So 180 plus 85 is going to be 265 degrees. There's a lot going on with this question, so I'm going to start off just having a look at the total amount of money. So I'm going to do this in pence, so 2115 pence. And if each merit point is worth 3 pence, then we can work out the amount of merit points by doing 2,115 divided by 3. So that gives us 705. So there's 705 merit points. Next, have a look at the question here, this part here, where it says James has X merit points. Sarah has 4 times as many points as James, so she's going to have 4x. Robert has 69 fewer merit points than James, so he's going to have x minus 69. And we know that that equals 705 because we've just worked that out. And this feels like a solving coming on. So we've got x plus 4x plus x, which is 6x. Minus 69 equals 705. And we're going to add 69 to both sides. So we've got 6x equals 774. Then we're going to divide 6 both sides. And so we've got x equals 129. So x equals 129. That means James has 129. Sarah has 4 times more, so she will have 516. And Robert has 69 fewer, so we're going to take 69 away from that, and that will equal 60. So for this question, we need to understand the different types of graphs from different functions. So if we have a reciprocal graph, it looks something like this and like this. It could be the other way around, and it could be distorted, but it basically goes down to a point along here. It goes to infinity, and it goes to infinity along a point over here. And obviously those positions could change. Then we've got a linear graph. A linear graph is just any straight line. So just any kind of straight line, either up or down. And this doesn't look like either of those. Then we've got a exponential graph. An exponential graph just starts really small and then just really increases like that and just keeps going up. And here we kind of have that, obviously the other way around, it starts going down, but here it's actually going up, so it can't be a reciprocal graph. So the graph that this is, or could be, is a quadratic graph because it's a nice U shape. So if we carry this on, it could be a nice U shape. It could also be a cubic graph as well. So it could go up and then down and then up, and that's a cubic graph. But the most obvious one is a quadratic graph. So quadratic function. So for this question, what we need to do is factorise 4t plus 6. Now factorise means put it into brackets. So if I try, what I can do is I can actually put a 1 on the outside here. So 1 times 4t plus 6 is 4t plus 6, but the question clearly states that it is higher than 1. So we need to find another number that's higher than 1 to factorise this with. So if we look at 4t and 6, well, they're both in the 2 times table. So I can put a 2 on the outside here. 2 times 2t is 4t, and 2 times 3 is 6. So what we can do is we can just check that out with smiles and rainbows. Put all my times down there to remind me to times it. So 2 times 2t is 4t, 2 times 3 is 6. So that works because that is the same as this in the question. So we know that 2 times 2t plus 3 works. In fact, it's the only one that works with it being an integer. So we therefore know that the known side, because it says it's a known number, is 2. And the other side will be 2t plus 3. And then when you multiply them together, you get the area of 4t plus 6. So our answer, because it says the length is the known number, so that's the length, then we're finding the width, which is this one here. So it's 2t plus 3. So let's just write out this sequence. So first thing we're going to do is work out what the sequence is going up in. And we can see here that we're adding 15 each time in our sequence. And whatever the sequence is going up in is what goes before n, so it's going to be 15n. Now 15n would give us the 15 times table, and this isn't the 15 times table. So to work out what the offset is, we go and find our 0th term. So instead of adding 15, when we go backwards, we're going to take away 15. And so that would be 10. And so our answer is going to be 15n, and we're going to add that 10 on. There's a lot going on with this question, so what I'm going to do is I'm going to put in all of the time signs that we don't normally show. So we've got 10 times 12x times y to the power 4 times 13 times x to the power 4 times y to the power 4. And I'm going to reorder these to put the numbers together, first of all. And with multiplying, it doesn't matter which way around you do it, so I'm not changing anything. I'm going to put the x's together. And I'm going to put the y's together. So, first thing to do is 9 times 13, which is just 117. Then we've got x to the power of 12 times x to the power of 4. Now we know when we multiply two powers of the same base, and the base is x on both of those, we just add the powers. So it's 12 plus 4, which is 16. So it'll be x to the power of 16. And then y to the power of 4 times y to the power of 4, we just add them together, so it's y to the power of 8. To find the resultant vector, we just get the two vectors and we add the tops and add the bottoms. And it's a plus minus 13, so it's 9 take away 13. When we do that, we get 13 at the top and minus 4 at the bottom. First thing we need to do is work out the volume of this prism, and it's a trapezium-based prism. So the volume will be the area of the cross-section, or area of the trapezium, times the length, how 3D the prism is. So trapezium is half a plus b h, and then times the length. Now a and b are the two parallel sides, which will be this one and this one. And then the h is the perpendicular line that hits both of them at 90 degrees, which is what perpendicular means, between the bases. So this will be the 25 meters here. So it's going to be half, and then we're going to add 1 and 5, times that by 25. The length is how 3D it is, so it would be that 10 there. we're going to times that by 10, and that will give us 750. So it's 750 meters cubed. Now, there is a little formula we can make for the rate. So the rate of anything for this will be the volume gained over time. Now, with this question though, we're interested in the time it will take. It says how long will it take. So we're actually looking at the time. So it will be time equals the volume, which is 750, over the rate, which is 15. So 750 divided by 15 is 50. So it will take 50, and let's have a look. It says per minute. So it would be 50 minutes. There are a few different ways you could answer this question. I'm going to do it with a tree diagram, but you didn't need to draw a tree diagram to answer this question. So we've got our first tree, which is our first bus. And the choices are male and female. And we've got our second kind of branch, I suppose. And it's still male and female. And this is our second bus. So the property of male on a first bus is 9 over 15. And therefore the property of female is 1 minus 9 over 15, which would be 6 over 15. Male on the second bus is 7 over 15. And so female would be 8 over 15, because they need to add up to 1. And it's independent, so these will be the same. And the question is basically asking what is the probability that both will be female. So to have both female, we need to have gone down this line at the start and then this line again. Okay, so looking at the fractions along the way, it's 6 over 15 and 8 over 15. The word and in probability means times. So whenever you're finding the probability of getting to an outcome, so this outcome will be FF, because they're both female, you are multiplying the fractions that you go across. So it would be 6 over 15 times 8 over 15. So 6 times 8 is 48. And times the bottoms, 15 times 15 is 225. Now you can actually cancel that down. So what you can do is you can divide top and bottom by 4. And that will give you 16. Is it 4? No. You can times top and bottom by 3. And that would be 16 over 75. So either 48 over 225 or 16 over 75. So we're going to write out the formula again just to give us a bit of space. And so we've got 4w over 7 plus 91. So going to first of all put our lines in because we're asked to make w the subject. So we need to remove everything that is in our way. Well, this plus 91 is the first thing we get rid of. So what's the inverse of plus 91? Well, subtract 91. So we're going to subtract 91 from both sides. So we've got a take away 91 equals 4w over 7. Next, we've got this 4w that's trapped in this fraction. So we've got to get rid of this fraction here. So that is over 7 or divided by 7. How do we get rid of that? Well, we times both sides by 7 because divide, the opposite there, or the inverse of divide is times. So we're going to end up with 7 times a minus 91. So it's timesing the whole thing equals 4w. The last thing we want to do is get rid of this 4 here. Well, that's a times 4, so how do we get rid of it? Well, the opposite of times 4 is divided by 4. So we're going to divide both sides by 4. So 7 brackets a minus 91 over 4 equals w. Now, some of you might be thinking that we haven't finished the question because we've got a bracket still. But actually, the bracket is absolutely fine to leave. We don't need to expand it. To find the length of the rectangle, what we're going to do is we're going to get the area and we're going to divide it by the width. Now, the question says that it wants the minimum length, so we want the length to be as small as possible. Obviously, to do that, we want the area to be as small as possible. If the area is smaller, the length will be smaller. But let's have a look at a couple of fractions. So let's have a look at a half and 1 over 100. Which one of those fractions is the smallest? Well, it's 1 over 100, but what do you notice about the denominator? That as the denominator gets bigger, the fraction gets smaller. So to make something smaller, we actually want the denominator to be as big as possible. So we want the width to be as large as possible. So we're going to find the lower bound of the area. And an easy way to find a lower bound is find the accuracy. Well, it says the accuracy is to the nearest 10. And what we're going to do is halve that. So half of 10 is 5. And then we're going to take it away from the area. So it's 98,540, take away 5, which will be 98,535. Now for the width, we're going to do the same thing, half the accuracy, half of 10 is 5, but we're looking for the upper bound, we're looking for the biggest it can be. So we're going to add that on, 1, 2, 3, 5. And when you do that calculation, you get the answer of 79.78542, blah blah, and it says it wants it to 4 decimal places. So we're going to do 79.7854. First thing to notice is we actually have 2 radii here. So we've got this radius here and this radius here, and all radii are always equal in length. So we have an isosceles triangle here. So this angle here is going to be 19x as well. And we've got to write that down. So we're going to say angle OBA is equal to 19x. And the reason is it's an isosceles triangle. Okay, so we know these two are equal. Well, we also can work out x because, as I said before, we have a triangle here, and all angles in a triangle add up to 180. So we've got 7x plus 19x plus 19x equals 180 degrees. And this is angles in a triangle. Try and draw a better triangle, equal 180 degrees. Try and write out these reasons in full. Okay, so that's going to be, was it 45x? Equals 180, and let's get our solving lines in, and we're just going to divide both sides by 45. Okay, so we've got x equals 180 divided by 45, which is 4. Now we're looking for this angle here, that's angle ABC. Now there's a few different ways we could do this. We could work out what this angle is, because it's a big triangle, etc, etc. Or we can use the fact that we've got a tangent touching a radius. So we know that this, let's just pick a different colour, this angle here is 90 degrees. So we can write that down. So angle OBC equals 90 degrees, because it's the angle between a tangent and a radius. Again, make sure you write all the reasons in full. And so therefore, angle ABC, which is what we're asked for, it's just 90 take away the 19x. Well, we know that 19x is 19 times 4, because we know that x is 4. And so that would be 76, so in total it would be 14 degrees. So angle ABC is 14 degrees. So we're told in the question that y is inversely proportional to the cube of x. So we can show that by y is proportional, there's proportionality, inversely, which would be 1 over the cube of x. Now to convert that alpha, the proportionality symbol, into an equals, we need to introduce a constant to the right hand side. So we get y equals k over x cubed. And all I've done to the right hand side is multiplied it by k. Okay, now we need an instance where we know what y is when x is something, and here we do have that, or it should be the other way around. What y is, well, yeah, what y is when x is something. So we've got y is 10 and x is 7. So we're going to feed those numbers into this kind of equation that we've made. So it's going to be 10 equals k over 7 cubed, or 10 equals k over 343. Okay. And then we're going to multiply both sides by the 343. So times by 343 both sides to find out what k is. And I'm just going to swap them around just to give myself a bit more space. And we're going to have k on the left hand side here. So that'd be 3,430. So k is 3,430. So what I'm going to do is just rewrite this equation here. But we know what k is now, so it's y equals 3,430 over x cubed. And that actually is our answer. So we first of all need to work out the frequencies in each of the bars. And we know that the frequency density is proportional to the frequency over the class width. So we're just going to go through each of these bars and work out what the frequency is. So all we need to do is times the frequency density by the class width. So 4.8 times 10 is 48. The second one is 0.4 times 10, which would be 4. And then the last one will be 0.8 times 5, which will also be 4. Work out the total frequencies. So it would be 48 plus 4 plus 4, which will be 56. So 56 in total, lines in total, and they only want to see the largest 20%. So we're just going to work out 20% of 56, which we can do, we can just multiply it by 0.2, and that'll give us 11.2. Now you can't have 0.2 of a line, so we can just round that to 11. So we're going to just quickly write out our sequence, so 9, 22, 41, 66 and 97, and we're going to find the differences of each of them. So that's going to be plus 13, then we've got plus 19, so they're different already, we know that it's not a linear sequence, and that's going to be plus 31. So we now look at the difference of the differences. And so we've got plus 6 again, and plus 6 again. When you have a difference of differences, it's going to be a quadratic sequence. And we're interested in what the difference of differences is, because what we now do is get that 6 and we always halve it, and it gives us 3. Now that 3 is actually really important, because that is the coefficient of the n squared. So we know our sequence will begin 3n squared. So we're going to do a table now to see what the rest of the sequence will be. And we're going to have our term number and our sequence. So term numbers will just be first, second, third, fourth and fifth. So 1, 2, 3, 4, 5. The sequence is just 9, 22, 41, 66 and 97. Now we know that 3n squared is part of our sequence. So what we're doing now is just removing the 3n squared bit and see what we have left over. So we're going to do 3 times 1 squared, which will be 3. 3 times 2 squared, which will be 12. And then 3 times 3 squared, 27. 3 times 4 squared, 48. 3 times 5 squared, 75. And we're just going to remove that from our sequence. So we've got our sequence, and we're removing the 3n squared bit, because we know what that is. We've already answered that part. So 9 take away 3 is 6. 22 take away 12 is 10. So they're not the same with this. 14, 18, 22. Now what do you notice? Well, we notice that these ones here are going up in 4s, so we've got a linear sequence here. So they're going up in 4s. So we know that that will be plus 4n. And then we find the 0th term. So we go back. So 6 take away 4, which will be 2. So it's going to be 4n plus 2. So our total quadratic sequence will be 3n squared plus 4n plus 2. A line that has a gradient of 0 will just be a horizontal line. So if you get your ruler and you just have a horizontal line on your ruler, so just have it as a gradient 0, and just keep moving down this graph until it becomes the tangent of the curve. So if you see, it becomes a tangent to that curve here. Where is it a tangent to? Well, it's a tangent to this coordinate here, which is at x equals 2.5. So we've got x equals 2.5, and you can see the y is 2. So the coordinates are 2.5 and 2. So simultaneous equations we normally solve by working downwards and doing the circles and using the normal method on them, which is solving simultaneous equations by elimination. Sometimes though, when we've got a linear and a quadratic, which we have here, it's not possible to do that method. So what we've got to do is substitute one equation into the other. Now here, it's actually been nice to us in this question because they're both equal to y. So I can replace that second y with the 2x plus 11. I can just put that into that equation there, which is what we're going to do. So we've got 2x plus 11 equals x squared minus 5x plus 4. And we're just going to get everything equal to 0 so that we can solve it as a quadratic. So I'm just going to start by subtracting 11 both sides. So we've got 2x equals x squared minus 5x, what's that going to be? That's going to be minus 7. And then take away the 2x both sides. So we're going to have 0 equals x squared minus 7x minus 7. Now, we know this is not going to factorise nicely because it asks it for 2 decimal places. It's on the calculator paper. Chances are it's going to be quadratic formula we'll need, which we do. So we've got a equal to the coefficient of the x squared, which is just 1. B equal to the coefficient of the x, which is just minus 7, and then c equal to the number unknown at the end, which is minus 7 also. So we write out the quadratic formula, so x equals minus b, and always put them into brackets, so minus 7, plus minus the square root of b squared, so in brackets minus 7 squared, minus 4 times a, which is 1, times c, which is minus 7. And all of that over 2a, so 2 times 1. And when you do that with a plus in that bit there on the calculator, we get the answer of 7.887 blah blah blah. When you do it with a minus, you get the answer of minus 0.887. And don't rewrite the whole formula when you change from plus to minus. Just use the calculator function to go back to this sign and just delete it and change it to a minus. But when we solve, we've got to find out the x and the y values. So we look at this first equation here, which says y equals 2x plus 11. It means to find out what y is, all we need to do is times it by 2 and then add 11. So I'm just going to do that with the first solution we have, so 7.887, blah, blah, blah. I'm going to times it by 2 on my calculator, and then plus 11. And that gives me the answer of 26.774, blah, blah, blah. Then I'm going to do that with the second solution we found, so minus 0.887, blah, blah, blah. Go times it by 2, then add 11. And that gives me 9.225, blah, blah, blah. So to 2 decimal places, our answers are going to be 7.89 and 26.77, or minus 0.89 and 7.23. You can complete a unique version of this paper by going to our onmaths site. Onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions, and mini mocks. If you like what we do, please consider subscribing.